Hey everyone, so in this video we're gonna go over problem C from the Pinely contest Codeforces called set construction. So essentially the gist of the problem is we're gonna be given a valid set and subset or superset relation in the form of this binary representation, right? And we're supposed to reconstruct the actual sets themselves. So basically, to reword, I'll just write it down so it makes more sense. So I'm gonna recreate this first example they gave us. So I think it's what 001. Okay, so the zeros really don't matter, but I'll just do it for this example. Okay, so just so you'll understand the code better and the solution. But yeah, so what this means, I'm still going over what the problem is saying. So they'll give us this, right? When they give us this, what this essentially means is, so this is row 1, right? Row 1, so the first set that we create is a proper subset of set 4. Similarly, for number 2 is a proper subset of 1 and 4. So wherever there's ones, that's where the subset is, and 3 is 4. 4 doesn't have any, but I'll just write 4 just like that. You'll understand just in a second. So based on this, we're supposed to reconstruct the sets. There could be multiple correct answers, they said, and we can do any of them. So what I ended up choosing is like the simplest one, and you'll see why. So essentially it's better to start with the set that has the most supersets. Okay, so in this case 2, right? 2 has 2 supersets, because you can think of it like constraint, right? Anything that's in 2 has to be in 1 and 4, because that's the definition of a subset. So it's best to start with those subsets that have the most elements. It doesn't matter which one. So like if this also had 1 comma 4, theoretically that's fine. You can start with 2 or 3, but always start with the one that has the most. Just it will make life easier. Okay, so keeping that in mind, we do this, right? I don't think you have to do this, but this is just how I ended up doing. I started with the one that's has the most. But the code essentially, here is the best, most important part of the code. So you choose whichever one you want. So we'll have a for loop essentially. So we iterate from 1 to n. Okay, n is the number of elements, in this case 4. We iterate from 1 to 4, and we just add one each element. So 1, 2, 3, 4 to particular sets based on these relations. So I know we only have 3 that are actually filled, but you can say 4 points to nothing essentially, or 4 points to itself. Okay, so as I said, going back to what this actually means, this means everything in 1 is in 4, right? So I know, as I said, we're going to start with 2 just because it has the most elements. So what this means is everything in 2 must be in 1 and 4. So since we're starting with number 1, we're gonna have 4 subsets. I'm just gonna call them 1, 2, 3, 4 for now. So because we're currently on number 1, we're just gonna add it to 2 and both of it parent sets. So 1 and 4. Okay, we're done with the number 1. Now we're gonna go to number 2, and now, as I said, you can choose either 1 or 3 because they have the same size, but I'll just go with 1 because it's just top bottom. So 1, we add 2 here, and its parent is 4. So that's the only constraint, right? The parent must have whatever the children has. Then we go to 3. Okay, 3 only has 4 again. So now we are number 3 because we just did 2. So we're gonna go 3, 3. And 4 doesn't have any parents, but as I said, it has itself. So you just go ahead and add 4, and that's it. This is a valid construction. It's actually not the example they give, but it works because obviously I passed the test, so I would know. But But yeah, that's like a really simple algorithm to do this. I'll do this on the other example too, because it's pretty straightforward. It's 0 1 1 0 0 1. I'll just do it here real quick to demonstrate that this algorithm works. But so here again, 1 points to what? 2 and 3. Yes. 2 points to just 3. 3 points to nothing. That's pretty straightforward, right? Because we're just converting whatever is here to this. That's nothing. We all should, with a little bit of coding, you should be able to do that in the code. I'll show you the code too, just in a second. But here's where the translation happens. Here we have a clear winner. One has the most number of parents. So we're gonna go ahead and do 1 1 1, because just like here, we add 1 to. We're iterating from 1 to 3 this time because n is 3. So 1 2 3. We added 1 to the actual one with the largest parents, most number of parents, and we added to each one of the parents. And then we go to the number 2, and here the second most is 2. This is a misleading example because all the numbers line up, but essentially 2 is added to this set and its parent set. That's how you should think about it, okay? And 3 obviously doesn't have any parents, so the number 3 just gets added here. But this first example is a way better demonstration of the algorithm. I'll go it with one more time. So this part, the schema translation or whatever you want to call this is easy, right? This is just manually doing it. Like any code should be able to do that. But here to here is the main algorithm itself. That's the gist of it. So we iterate from the numbers 1 to n, not the sets. These are sets, okay? These are sets on here. I know it's confusing. This part is sets. These are also sets. These are the actual numbers in them. So we're iterating from 1 to n, and then we just add them based on the sorted sets. Makes it simpler because 2, so set 2 has the most elements, so it's the first set we're gonna end up using. So for set 2 we add the element 1, but we also have to add to all of its parents, which are 1 and 4. So we added 1 and 1 there. And then as I said, it can 1 or 3, it doesn't matter which one you choose next. The number 2, I just chose the first set. The number 2 is added to the first set and its parent. And then the next one is set 3. Here once again number 3 is added to this and its parent. And set 4, obviously no parents, so just itself. And that's it. We just display this, and the code for this is right here. So I split them into parts. First we create the set superset vector, which is here to here, the translation. It's pretty straightforward, I would say. After that I sorted the vectors using a comparator function, nothing crazy there. And then adding each number to appropriate set and superset, as I said, from this step to this step, okay? As you can see, I iterated from 1 to n, and we sorted the array. Remember here above, we sorted the array. So the set with the most number of parents goes first, and so on like that. And this is just displaying the answer. So it's pretty straightforward, I would say. It's a nice question, a little bit of number, not really a lot of number theory really. It's just you need to build set. Yeah. So thanks for watching. Let me know if you guys have any questions.